Hi guys, welcome back, and in this lecture I'm going to be showing you how to count MandMs. We are going to be creating your first lab view app. Okay, so first of all, go to open image. We want to select, we can select any one of these MandMs, but I think for testing purposes we should choose this one, which is called test.png. All these datasets will be in the resource section of this lecture. So go ahead and select test.png, open. It's going to make this a full screen, and click on this button to make sure you can see the full view of it. Okay, so what we want to do is to basically count the different MandMs. We have blue MandMs, green, red, brown, and yellow. Okay, so first of all, we go to color location. Let's try that first. Okay, so now how this thing works is first you create a template. Normally you create your template from a test dataset. Then you try it under your main dataset. So let's go ahead and create a template. Just minimize this. So press or shift and click. Then we click this square over here, and then we select our region of interest that we want to be our template. So we'll choose this one because it is easily distinguishable. Click OK. And then we save this one as, you can save it as anything. So we can say template MandM. Press OK. Okay, so now we have created our template. Our template part is where our template is stored. We can choose to ignore black or white. Now, if you don't know what half these functions do, you can click this question mark over here, and it will tell you what each function does, or each parameter. We can ignore black and white, so basically anything that's black or white, it will ignore. So like in the background, it will ignore that white or that white. It will only look at the color. Then we go to settings, and then we can see this one here has the highest ratio of blue. Now we want to detect all the blue MandMs in this picture, and you can see it does it really quite well. So number of matches to find, I put 9, but in this image there are 1, 2, 3, 4, 5, and this also detects 1, 2, 3, 4, 5 MandMs. You can play around with these settings to see what works best. The minimum match score is basically the sensitivity of your detector. So the lower the sensitivity, the more prone it is to detecting erroneous MandMs or erroneous objects in the image. But it will be more likely to detect the ones that you want. Now, as you can see, this is the score. This one is 1000, or as in 100%. So that's because it is matched to our template exactly. So there is a high correlation between this and our template image. And the rest are above, say around 90%. Say this one is around 80%, 85%. Increase that. And you can see color matching works quite well in this case. So let's bring it up to 700 again. Okay, so this may not work 100%. This may not be a robust app, because if these MandMs were grouped together, it will detect it as one MandM. So that's what you have to keep in mind. So especially in this case here. Okay, so as you can see, we have detected 1, 2, 3, and you can see what, as I was saying, what happens. It detects us here as one blob as opposed to two different entities. Now, one way to get around this is to basically use template or pattern matching. Template matching uses normalized cross-correlation, which I shall discuss with you at a later stage in this course. But this one is solely based on color and not the different features of the image. Okay, so let's take a look. You can just go back to the blue one. Load from file, templates. Let's go to this one here. Go ahead and click OK. Okay, so as you can see from this algorithm, our host machine, which is this computer that I'm using, if I had to process this image in real time, I would only get a frame rate or frames per second at around 4 frames per second. Now, this is not relatively good for real-time applications. If you want to go real-time, your frames per second will have to be above 15. Okay, and if you look over here, you can see what algorithm is using the most. So on average, to process this image, it is taking 263.55 milliseconds. Now, if you want to minimize this, we can reduce our region of interest. So to reduce our region of interest, we go back to this algorithm here and we make this thing smaller. And you can see we're still detecting the same amount. Now, if we have prior knowledge, we can reduce our area to just that area, right? Click OK. And then we click our performance meter again. So basically, you'll notice that our algorithm will have speeded up because we are processing less part of the image. It's slightly higher, but not as high as we would expect. And because we're processing less pixels, our performance has improved of this algorithm. Now, obviously, there are faster ways to detect objects in an image. This is just one of the ways, but it's not the optimized or fastest way to process images or to detect objects in images. Okay, so let's go ahead and create our LabVIEW VI or our LabVIEW app. So we'll just choose, call it MandMs. Okay, this will create our VI. Create next, current script, image file. And now you can choose what you want, what parameters you want to edit. So I want to edit our region of interest, the color sensitivity, okay, mostly the minimum match score and the number of matches requested. And this will show how many matches and the number of matches. Okay, click finish. Just wait a while until LabVIEW opens. Now you can see our app being automatically created, which is a really good thing about prototyping in LabVIEW as compared to OpenCV or SimpleCV or basically any other vision-based development tool. I think this is also easier than MATLAB, but also keep in mind that MATLAB has a vast range of algorithms that they have at their disposal. Okay, so in LabVIEW, you can click play. Okay, now it'll pop up with your select image file dialog. Select the folder where it is, and then we click on our dataset. So that's that one. Okay, so over here, we can see what happened. It shows us the number of matches. It shows us the match locations. So if we go and drag this down, it'll show you the XY coordinates of the center of the bounding box that surrounds the blue M&Ms. Now if we go into the code, let's just go through and see what's happening. Now the only problem with this algorithm is that it does not overlay the matches. I will show you how to do this in the next app, but for this app, let's just go through the code. Okay, so we start off with our image dialog. It opens a IMAC, which is the image processing acquisition library. It takes that file argument and then reads that file, sends it through to you, and then it basically puts it into a while loop and then into a case statement. And false passes it through, and true discards the image and takes only the relevant information and passes that through. Over here you can see it sets the parameters. These parameters are set from here, and then it does the matches based on that. And then the output gives you these matches over here. And then basically the algorithm ends and then gives you your image out. Okay, so I'll see you in the next lecture where we'll do some object tracking. And I'll show you how to track a colored ball in free space. Okay, see you then.